Hey everybody, it's Mr. P here back with another video for you guys. It's going to be the April 16th video. First thing I want to mention is for all the people that are staying on top of things, doing their Google Docs on a daily basis, I really do appreciate it. Hopefully all this stuff is making sense. And if you are struggling, make sure that you reach out to me on Google Classroom, Google Hangouts, email, whatever it may be, because I do want to help you guys out, all right? So again, thank you for the people that are doing exactly what it's supposed to do. It will pay off for your grade, and if you need anything, do not hesitate to ask. All right, so you guys, lately we've been talking about square roots, or what math people call radicals. Now, we've learned how to simplify or reduce a radical. We've learned how to add or subtract radicals, and today we're going to learn about multiplying radicals. So the big thing is, and I kind of do like little melodies or little silly stuff, is I just kind of make sure that I know when I'm multiplying radicals, first of all, they don't need to be like terms, but I just go outside times outside stays outside, inside times inside stays inside. It lets you organize the pieces where they're supposed to go, and then from there, you still have to break down inside the radical to see if there's pairs. But all right, with that being said, I got a square root times a square root. So I consider there to be two pieces of a square root, an outside and an inside, an outside and an inside, and both of those fives are insides. So I have my square root, and I say an inside times an inside stays inside. Now, I could multiply that to 25, but I like it in this format because what do I see? I see a pair. Please remember that we always look for pairs underneath square roots. So a pair of fives gets to come outside as a single five. So now I have a 5 on the outside, and when I put my square root symbol, what is going to be left over is nothing. So you guys, if you ever have a square root symbol and you have nothing to put in here, you shouldn't reference it at all. So 5 square root of nothing is just 5. So you guys, this is actually a quick rule that we should know. If the square roots are exactly the same, it becomes just that number, and it's always true. So we could add a little extension here, and I'm going to say QR for quick rule. But if I have the square root of 10 times the square root of 10, without doing any work, that answer will become 10, because I would have a square root of 10 times 10, and a pair of 10s get to come outside, and there would be nothing left over. All right, so if the square roots are the same, it's no longer a square root, guaranteed. Here is number 2, though. Number 2, I have a square root times a square root, same thing. An inside times an inside stays inside. So I need a square root symbol, and I'll take 3 times 7. Now I look to see if I can break these down or if I have any pairs. 3 is a prime number, so it doesn't break down. Neither is 7. So the only thing I'm left to do to reduce this is actually multiply them out for 21. Square root of 21 is your final answer. But now let's see whenever we can get pairs. So I have a square root times a square root, and they're both insides, the 6 and the 10s. They're actually called radicands, is the fancy term for underneath the square root or inside of it. So I'm going to take an inside times an inside stays inside. So I put my square root symbol, and it all stayed inside. But what do I notice about 6 and 10? They're both composite numbers, so I can actually break them down to primes. 6 is 2 times 3. 2 is prime and 3 is prime. 10 is 2 times 5. 2 is prime and 5 is prime. Now I look for pairs, and you might be able to visualize that. You might be able to see that that is a pair of 2s. But if the factor trees are ever a little bit kind of spread out, you can't really see pairs as well, you're free to write a square root symbol and write all those prime numbers in order from smallest to biggest, and maybe you check them off when you do them. So a 2 needs to go under there. Times, there's another 2. Times, there's a 3. Times, there's a 5. And all that is under the square root. But a pair comes out as a single. So on the outside is 2. Square root, 3 times 5 trapped inside is 15. So my final answer is 2 square root of 15. All right, we have 2 more examples before our notes are over. And please remember, you can just listen and then pause when I'm done and copy all the work if you feel like I'm going a little too fast. That's the nice thing about these videos is you can pause, you can rewind, go back, watch them over again. All right, here is number 4. 8 square root 6 times 5 square root 3. This is the first time that we've seen numbers outside of the square root, but we just leave them outside the square root then. So you guys, I actually start with the square root symbol usually, and I go outside times outside stays outside. Usually I would just multiply them right away and say 40, but I'll actually show 8 times 5 to show you that the outside times outside stays outside. And then the inside times the inside stays inside. So now as I break this down, I see 6 is 2 times 3. Prime number, and 3 was a prime number. So what I actually notice is there's a pair underneath this square root that's going to get to come out. The pair of 3's gets to come outside as a regular 3. So you guys, what I really have in this problem is an 8 was on the outside, times a 5, times now a 3 is on the outside, square root, 2 is the only number that is trapped inside. And 8 times 5 is 40, times 3 is 120, so I have 120 rad 2. Last example of the day, number 5. We're going to have negative 4. Rad 14, remember I say rad instead of square root a lot, times rad 5. This one might be a little bit tricky for people because there's an invisible number. And they might think, well, that negative 4 is outside, what's the other outside? If you don't see the outside piece, you can always put the invisible 1. So now I go my outside times outside stays outside. I put a square root symbol, because the inside times the inside stays inside. Now 14 is a composite number, so I can break that down to look for pairs, but 14 is only 2 times 7. Now 2 is prime, 7 is prime, and 5 was prime. So in the last couple examples, you've seen where the square roots have had pairs and they got to come outside the square roots. That doesn't have to be the case. So in this problem, I'll do negative 4 times 1 is negative 4 on the outside. I'll put my square root symbol, and I have to take my 2 times my 7 times my 5, which is a total of 70 on the inside. And I did that multiply problem. Make sure that you guys are doing your notes. You're copying these down on a brand new sheet of paper, labeled, and then you're going to do these homework problems that I'm going to show really quick to you on the screen. And you also include those in your picture in your Google Doc so you can get full credit for participation. Please reach out to me if you need help. Otherwise, I hope you're staying safe and healthy. And you guys, it's your boy, Mr. P. Here are your 5 homework problems to please try. Let it zoom in. And again, you can pause it right here and copy them down. All right, have a great day.